Okay, problem 5. Determine the radius of convergence. Okay, so here you need to use a ratio test. Okay, so to use a ratio test, you have to get the limit of the absolute value of x an plus 1 over an. Right, and you want the ratio to be smaller than 1 later. Okay, so an plus 1 is just x plus minus 1 to the power of n plus 1, right, over square root of n plus 1 over an. An is x minus 1 to the power of n over square root of n. Okay, the absolute value. But here I have top over bottom, so it's just x minus 1. Okay, it's just x minus 1. And then times the square root of n over square root of n plus 1. Okay, you can see for this part, it is actually, this limit is going to be 1, right? Why? Because as n is very, very large, you can see the square root of like a million is very similar to the square root of 1,000,001. Okay, so essentially this part is going to be 1. So the result is just the absolute value of x minus 1. And you want it to be smaller than 1. Okay, here the x coefficient is already 1. So this will be the center. 1 will be the center. Okay, the a is 1. Then this 1, it's the radius of convergence. Okay, the r is also 1. So, part B, your an, right? So the series is from 1 to infinity, x to the power of n over n times 3 to the power of n. Okay, so again, use a ratio test, so limit of absolute value of an plus 1 over an. Okay. So it's a limit of an plus 1, it's x to the power of n plus 1 over n plus 1 times 3 to the power of n plus 1. Okay, over x to the power of n over n times 3 to the power of n. Okay, so here, the top over the bottom here, x to the power of n plus 1 over x to the power of n, you have just nx left. Okay, then here you have n put onto the top, it's n over n plus 1. And then you have 3 to the power of n put onto the top, so it's 3 to the power of n over 3 to the power of n plus 1. So they cancel out, you just have 1 over 3 left. Okay, then this limit, right, this limit you can also easily prove it will be 1. So the final result is just 1 over 3x is equal, right, it's just the absolute value of 1 over 3x. And again, you want it to be smaller than 1, which means you want to make the x coefficient is 1, so it's x minus 0's absolute value is smaller than 3. Okay, so here this is your center, it's 0, and the radius of convergence is 3. Okay. Part C. Okay, so part C, my series is negative 1 to the power of n times x to the power of 2n over 2n factorial. Okay, so this is, again, the limit of the absolute value of an plus 1 over an. So an plus 1, it is negative 1 to the power of n plus 1 times x to the power of 2n plus 1 over 2n plus 1 factorial. Okay, that is an plus 1 over an. An is just copy it down. Okay, so here, my negative one, right, because I have an absolute value, so later it will just disappear, so I don't need to care about these two parts. And here the top is x to the power of 2n plus 2 over the bottom x to the power of 2n, right? So I have x to the power of 2 here. And then here the bottom 2n factorial, I put it to the top, it's 2n factorial over 2n plus 2 factorial. Okay, over 2n plus 2 factorial. Right, so this, again, they can be canceled out. It is just x squared times, so it will just be 1 over 2n plus 1 and 2n plus 2. Okay, and you can see for this limit, right, as when n approach infinity, this will approach 0. So as long as x is a real number, this is always approaching 0, right? So this limit is 0. So it's always smaller than 1. Okay, which means for any value of x, this is convergent. Okay, so for any of x, this is convergent, then the radius of convergence. Right, then the radius of convergence it is just infinity. Okay, because for any value of x, it is convergent. Then for the last part, it is n factorial over 3 times 6 times 9 times all the way to 3n times x to the power of n. Okay, so first let's simplify it. 3 times 6 times 9 times all the way to 3n. So 3 is 3 times 1, 6 is 3 times 2, 9 is 3 times 3, times all the way to 3n is 3 times n. Okay, so I have n 3's here. So put them together, it's 3 to the power of n. And I have 1 times 2 times 3 times all the way to n. I put them together, it's n factorial. Right? So this is actually n from 1 to infinity, n factorial over 3 to the power of n times n factorial. Okay, you can see this is actually x over 3 to the power of n. This is a geometric series, right? This is a geometric series. So the geometric series is convergent if only if the absolute value is smaller than 1, right? Which means the absolute value of x minus 0 is smaller than 3. Okay, so the center is 0, the radius of convergence is 3. Okay, so that will be all for problem 5.